Now, what would you expect a native prairie soil to look like compared to maybe a wooded or a forested soil? Native prairie will have such a nice thick mat of roots and such there that'll be nice and dark and deep. And so if we have a nice dark deep surface and it hadn't been eroded or man hasn't scraped things off, when I see 10 or more inches of dark deep soil, I start to think that that's probably had some prairie influence. All right, how about if we go over in the woods about a half a mile? Think about a tree. What happens in the life cycle of a tree? What's going to happen this fall? The leaves are going to fall. The roots won't die off, and so what would you expect the surface soil then of a forest to look like? Is it going to be nice and thick and deep like this one? It may only have 3 or 4 inches. It may be very dark with that leaf litter and leaf mat there. So when we see something like this, now if this had been under prairie the whole time instead of the climate change and back and forth, I would expect this under a native prairie to probably be about that dark and deep, somewhere in there. But this thing is waxed and waned, but it's still got a lot of good features of a native prairie. The other thing is if we would look at this under a microscope, a native prairie will leave some opaline bodies in here. It's called opophytolus, and that's what grasses sequester some silicon, and we'll see some of that in there. You won't see that under a forest. Now, what makes this soil unique to support grasses? The climate you mentioned, okay? Another thing is the parent material. We've had glacial materials being deposited here. We're almost on the southern edge, but this has material that's been blown in from the Missouri River. It's called loess. It's a wind-blown silty material. Very good fertility, good water holding capacity. Time. Soil has to weather over time. We've got a climate here, 38, 40 inches of rainfall, temperate. Slope, the topography. What does this look like to you? It's pretty what? Flat? So this doesn't erode, and so what does that tell you when it rains? It sinks in or it's wet. And then soils change as they go over time. We talk about in soils, young soils, mature soils, and then old soils. Soils change, and so their biology will change, a whole, like your blood chemistry changes as you get older. So this soil is very unique. It's one of the few prairies left that has not been cultivated. Now, what makes a prairie unique? Why are we out here today besides the fact we're having fun? It's very diverse biologically. All right, we've got many different species. You've been collecting, what, butterflies and insects here? Did you get a lot of different species? Guess what? Down in the soil, we even have more diversity. Patty Quackenbush, working on her PhD.
So, Dr. Miles has talked about the fact that, organisms are one of the 5 soil-forming factors, right? So most of the time when we think about that, we just think about plant biomass, right? We just go right to the vegetation. But there's a lot of stuff happening below ground too. So we've talked about earthworms, right? What are some other organisms that live below ground?
Rabbits.
A little. Mostly superficial, but do kind of burrow in a little bit. What else?
Moles.
Moles? Sure.
Shrews.
Shrews? Sure. So you have voles, shrews, other field mice that can get in there. We talked about earthworms. What other organisms are about the size of earthworms-ish that live in the soil? Insects, right? So we have this huge umbrella term called soil-dwelling arthropods, all right? So that would include ants, termites, crawdads, grubs, other types of worms that aren't earthworms, okay? Think even smaller than that. What could be smaller than that lives in the soil? Bacteria, right. So how many of you have heard of anthrax? Anthrax is a bacteria that occurs in soil. There's a Staphylococcus bacteria that lives in the soil, right? How many of you ever gotten sick and had to get an antibiotic? Right? There's an organism called actinomycetes, which most of our antibiotics are derived from, that comes from the soil. I want you to go through these trays, and so hopefully we'll find some soil activity going on. It is cold today, and so a lot of organisms do need warmer temperatures since they are what we call ectotherms. Right? Has anyone heard the term ectotherm? No? Okay, ectotherms rely on the environment to regulate their temperature. Right? So if you've ever seen a snake sun on a rock or a turtle on a log try to get themselves to warm up, So obviously the soil organisms for the most part are in that group as well.